Hi everyone, welcome to your homework 5 solution video. We're going to start with our first question, array input for built-in functions and operators, part 1. So this is basically an overview of what this entire homework is designed around. So this time we're going to learn how to manipulate arrays without using loops, and instead we're going to be using built-in functions and operators. Okay, so let's get started. So we've been given a bunch of information already, so let's take a look at what these are. It's important to read all the comments beside all the predefined variables because that gives you a good idea of what it is. A lot of times we get questions about students being unsure about the size of mat 1, mat 2, but most of the times you have comments here defining the size, so please make sure you read all the comments. They can be a big hint, especially during your quizzes. Okay, so n is a randomly generated number. Mat 1 is an n by n matrix and its elements are randomly generated from minus 50 to 50. Mat 2 is again an n by n matrix, however the elements are generated from 1 to 100. And mat 3 is 6 by 7 with random elements from 1 to 45. Alright, so now we also have a vec1, which is a 4n by 1 column vector, and the elements in it are randomly generated from 1 to 100. So we have 4 types of vectors, 2n by n, 1 6 by 7, and 1 4n by 1. Okay, so let's see what we have to do for our answers. The first thing is, okay, before I start reading the questions, I'm gonna copy the given script from here. Copy and paste here. Okay, and let's also label part A. Okay. All right. So write a script that creates a variable named num neg even, which is a scalar value containing the number of negative values which are also even from mat 1. For example, mat 1 is, these are the values, and num neg even is 2. Why? Because you have this minus 4 here and you have the minus 10 here. Okay. And also, if you notice at the end of this question, it clearly states, please do not use a loop statement to solve the problem. So make sure you read any kind of highlighted text at the bottom and don't start the question right away with a loop, okay? So what are the two conditions I need to satisfy for this question? The first thing is that my number within the mat 1 needs to be negative. And the second condition is that it also should be even, okay? So I'm going to define a mat temp. This is a temporary matrix which is going to tell me which positions, or like which numbers within mat 1 satisfy both of the conditions. So what's my first condition? It is that the value is negative. How do I check for a negative number? I can either check for less than 0 or I can check that it has a negative sign in front of it. So since we are working with built-in functions, I'm going to show you how to use the sign. So I'm going to say sign bracket mat 1 double equal to minus 1. So this way it is going to form a logical vector that is going to give you the position of every element within mat 1 that is a negative number or has a negative sign, okay? What is the second condition that I need to satisfy? That the number is even, and we already know how to check for even numbers. It is very simple. It's rem mat 1 comma 2 double equal to 0. So that's how you check for even. Now I have my first condition right here and I have my second condition right here. We have seen before that when we have two conditions and we need both to be satisfied, we use the AND operator. However, we are used to using the double AND operator. The important thing to know here is that when do we use the double AND? When you are comparing two scalar values. However, in this situation, the output of sign mat 1 double equal to negative 1, and this is not scalar values. Both of these are going to be logical vectors. Why? Because you're not specifying a single position or a single element within mat 1. You are specifying the entire matrix, so the output will also be a matrix. So how do you compare two matrices? You need to use the single AND operator. Please check your notes for this particular operation and make sure you never use double ANDs with logical vectors. With logical vectors, you're going to be using a single AND. With logical scalar values, you're going to be using the double AND. All right. So that's my temporary matrix. Now, how do I get the number of negatives? So the answer of mat temp is basically, let's try running it. Okay, so if I look at mat temp, this is an 18 by 18 logical, and okay, so it has 1 in all the positions where the values in mat 1 satisfy both conditions. So to get the number of digits that satisfy both conditions, my answer should be, this is num neg even. My answer should basically be the sum of all values in mattemp because it's all of those ones, right? And adding all of them, I am going to get mattemp, comma, all. Yeah, every single value within mattemp. And that is going to give me the total number of negative and even numbers within mat1. Okay? All right. This is a very important concept, and we're going to be using this for multiple questions in homework 5. Okay, let's visit the second question. So here it's eqval, which is a column vector, contains the values of elements in linear indexing order, which are equal to each other at the same position in mat1 and mat2. For example, mat1 is 1, 2, 3, 4, 5, 6, and mat2 is 1, 7, 9, 4, 5, 9. Okay, so we do see 1, 4, and 5, which are common, and it contains those of the it contains those particular values in linear indexing order. Okay, since those three values are equal to each other and in the same positions. All right, so now what are we going to do? We have to check which elements within mat1 are equal to mat2 and in the same position. So I'm going to define a random variable called idb, which basically gives us the particular ID of the elements. And I'm going to say mat1 double equal to mat2. Okay. And then what do I want? I basically want those elements in my eqval, right? So all I have to do is say eqval equals to mat1 bracket idb. Why would this give me the right answer? Because the elements are in the same position in mat1 and mat2. So I could use either one here, and here I choose to use mat1. Okay, so that is part B for you. Let's go to part C. All right, mat3, which is a scalar containing the median of the highest 6 numbers in mat3. For example, this is a vector given and it contains the median. So we already know that to find the median, we already have a built-in function that gives us the median. However, the tricky part here is that we need the median of the highest 6 numbers. So if I give you a random jumble of like a lot of numbers, how would you pick the highest 6? Suppose this vector is really long. It's like 1,000 digits. And if I just give you 1,000 numbers and I'm like, get me the highest 6 numbers, it would be hard for you to actually go through the entire vector and pick 6 numbers that are the highest. So how would you prefer me to organize the data to get the maximum 6 or minimum 6 really quickly? So if you think about it, the best way to do is sorting that array, right? So what are we going to do here is exactly that. We're going to sort our mat3 and then pick out the first 6 digits, and we're going to sort it in a descending way, so we have the maximum 6 in the first 6 positions. Okay, so I'm going to call it vec sort, and I'm going to say sort bracket mat3 all, because I want the entire matrix to be sorted, and in what order I want it to be? Descend. Oh, I hope I spelled it right. Okay. All right, and what is my mat3? So this is basically the median of the first 6 elements of vec sort. So I'm saying median vec sort bracket 1, 2, 6. All right, please be sure that you are using the colon here, because colon means 1, 2, 6 elements, and a comma would mean the first row 6th column element. So be really careful while using that symbol right there. Okay. All right, so that's my part C. Let's move on to part D. Let's see. IDXval6, which is a vector containing the index location according to linear indexing of elements equal to 6 or minus 6 in mat1. For example, you have your matrix right here. You have minus 6, 6, 6 in these locations, and according to linear indexing, it is position 1, 2, 3, 4. So it's 1, 2, and 4, right? So let's try this. What is the first thing we need to do? The first thing I need to think about is basically finding which locations have a 6 or a minus 6. To make my life easier and not having to write multiple statements, I will use the what's it called? The absolute function. So I'm going to define a variable called location. So log is basically absolute value mat1 double equal to 6. So that will give me the positions of everywhere in mat1 that is equal to either 6 or minus 6. And then what I need to do, I need to say idx val 6 equals find and bracket block. That's all. This will directly give me the linear indexing positions. Why? Because I just have one variable right here, right? The find function can also give you the row and column location, but for that you need to define like a little vector there having like a row variable and a column variable. This will directly give me the linear indexing values. So that is all for my part D. Moving on to part E. Okay, so part E is vec1 between, which is a logical value containing a logical 1 if any of the values in vec1 lie between 64 and 67. Otherwise, it contains a logical 0. So it basically already stresses on this word any. So I already know it's hinting towards me using the any function, right? And what are the two conditions I need to satisfy? I need to make sure that the element in vec1 is greater than 64 and the element in vec1 is also less than 67. So I'm going to define that like this. I'm going to say is vec1 between. So let me write out my conditions first. So it would be and bracket vec1 greater than 64 comma vec1 less than 67. Okay, so these are the two things. And what do I need to check? I need to check if there's anything in vec1 that satisfies both these conditions. So I'm going to write an any at the beginning and put all of this within that any function. Okay, and that is all for my part E. Now let's run this, and it's running properly. I have all of these vectors, which are the outputs. It looks good to me, and I'm going to copy paste this in my grader first. If there are any issues in any of the subparts, then I'm going to come back to the workspace and look at each of the individual outputs. Okay, use your workspace to check your work sometimes, especially when you have a mistake, because that greatly helps you pinpoint the exact place you're going wrong. Okay, so I guess my script starts from here. Let me, oh no, please stay there. Yeah, let's copy everything and paste it here. All right, I'm gonna submit it. Oh, okay. My is vec1 is wrong. Oh, I think I know why, because I think, oh yeah, I misspelled my name. It should be is vec1, not id vec1. So let's submit that. Yep, now it's all correct. I'm also gonna correct that right here. There you go. We're now starting with homework 5 question 2, array input for built-in functions and operators part 2. So this is basically a continuation of homework problem 1, and this is a slightly difficult variation of the same. So once again, we've been given a bunch of random variables and matrices. The first one is n, which is a random integer. mat1 is an n by n matrix. mat2 is an n by n matrix 2, and vec1 is a 1 by 4n row vector. Okay, so it's really similar to the given things in question 1. Okay, so once again, if I scroll to the bottom here, I can see that there have been instructions here that please do not use a loop statement to solve this problem. So we know that no loops are allowed and you have to use operators or built-in functions. Please make sure when you have instructions like this that you absolutely do not use loop statements, because we always have an assessment here that checks if you're using any kind of for while loops, and they will be marked at a 0. Okay, all right. So any neg, which is a logical value containing logical 1, if any of the values in mat1 are less than 45. So we have seen a problem like this in our previous question, and let us follow the same procedure. Okay, oh sorry, not 45, this is minus 45. Be careful with the signs. Okay, before I start, I'm gonna go here, I'm gonna copy everything and paste it right here. Okay, I have my part A here. Okay, what was the name of my answer? It is any neg. Okay, so any underscore neg. All right, and what is this supposed to be? This gives you a hint that you have to use the any function. And what is my condition? Any element in mat1 is less than minus 45. So I'm going to write down my condition first. mat1 all elements less than minus 45. So this is my, this is my condition. And I need to check if there is anything in mat1 that satisfies this. So I put an any function before this and close the bracket. There you go. And that is it. That is my first answer. Moving on to part B. Alright, so mat pos, which is copied from mat1 and where all positive elements are replaced with a 0. Okay, so the first thing, I'm going to go step by step. It says mat pos is copied from mat1. So I'm going to say mat pos and I'm going to say this is equal to mat1. So that's, oh, that's not minus. That should be equal to, my bad. Okay, that's the first thing I do. And then what do I need to do? I need to replace all the positive elements and make it 0. Okay, so I am first going to get a logical vector that is going to give me all the IDs. So like all the positions where I have positive numbers. So I'm going to say ID pos equal, what are we checking? That any positive values within mat pos. So this mat pos greater than 1. Oh, sorry, not 1, 0, right? Positive. All right, and now what do I need to do? I need to convert all of these positive values into a 0. So I say mat pos, because that's the matrix, bracket ID pos. Why this? Because I am trying to convert the positions within, like the positions which are defined by ID pos in mat pos to 0. Oh, sorry. Okay. So be very careful when you're writing a statement like this. You can't just write ID pos equal to 0 because that would not make sense. It is those positions within mat pos that have to be 0. Okay? All right. Now moving on to part C. What does it say? Mat EQ, which is copied from mat 2, if an element is at a given index is not equal to the element at the same index in mat 1, replace that value with 0. So the statement is a little confusing, so let's read it again once to be clear. An element at a given index is not equal to the element at the same index in mat 1. Okay, so the first thing I once again do is follow the question exactly. I have my mat EQ and I'm going to make that a copy of my mat 2. So that's my first step. What's my next step? I need to check which positions within mat EQ or like mat 2 are not like in the same in the same index as mat 1. So I'm going to call that ID, say EQ, right? Equals mat 1 not equal to mat 2. So this is a logical vector logical matrix containing all the positions where they're like the element at a given index is not equal to the element at the same index in mat 1 and mat 2, right? And now what do I need to do? I need to convert everything within mat EQ in these positions to a 0 once again. So I will be following a really similar style from this one. So I'm going to say mat EQ bracket ID EQ equal to 0. Do you see the resemblance between the two? Okay. Now we move on to part D. Okay. Mat diag, which is copied from mat 2. If a diagonal element is even, replace that value with 10. For example, when mat 2 is, it's a given mat 2, and then the mat diagonal becomes the same mat 2, except do you see this 8 and 2 right here? These are on the diagonal and they're even numbers, so now they're replaced with 10s. Okay. So for this one, what we're going to do is again start by defining mat diag equals mat 2. So one way to do this is we know that the numbers that need to be converted to 10 need to satisfy two conditions. So when we were playing around with these numbers in part B and C, they just needed to satisfy one condition. So in part B, they had to be greater than or equal to 0. For part C, they did not have to like match those elements in mat 1. So let's start by defining the conditions my numbers need to satisfy in order for them to be changed to 10. The first condition is that they need to be even. So I'm going to say ID even equals rem mat 2 comma 2 double equal to 0. All right. So this gives me a logical vector that shows the position of all the even numbers in mat2. What's the other condition that I need to satisfy? I need to satisfy that like those numbers are in the diagonal. So to make that, I'm going to say id diag equals, how do I get a matrix that is full of zeros except for just the diagonal? So do you remember the identity matrix? That's exactly what we're going to be using. So instead of just the identity, I'm going to convert that into logical values, because this is a logical vector. We need logical values. So I'm going to say logical bracket I, and the size is going to be n, right? Okay, so now this is my first condition and this is my second condition. Which one do I need to be changed to 10? Only those positions which satisfy both. So how do I get a final logical vector that has ones in the position that satisfies both conditions? There I'll be using the AND operator, the single AND, because these are both matrices. These are not scalar values, right? So I'm going to say id even diag. So both conditions equals id even and id diag. All right. And finally, after this, what do I want? I want everything within mat diag, which is in these positions, to be converted to 10. So again, similar logic. I'm going to say mat diag bracket id even underscore diag equal to 10. All right. So that is the solution for part D. If you're confused about it, take a while, run each part of the code and see what the logical outputs are, and that'll help you clearing any confusion here. Okay. Another way to do it is this. So I'm just going to write an optional code right here. So we can start by saying logical mat2. So I'm just going to copy this. I'm just using a different variable because I don't want to repeat the variables. So I'm going to call it this. It's basically just checking which positions in mat2 are even. That. Then I'm going to define another, which is diag lm, which is basically just the diag elements, right? So once again, it's just this. All right. And then what do I do? Now I say that LG mat2, so LG mat2, so everything within LG mat2 that is not a diag lm. All right. So keep in mind that LG mat2 is a logical vector, okay? So this has logical values throughout mat2 that contains even numbers. And I'm saying within that logical vector, anything that is not a diagonal element, right? Because this is just diagonal elements, that is equal to 0. So basically, I end up with a logical vector that has all the even numbers, like any number that was originally even in mat2 is a logical 1. And that's only in the diagonal. Everything else has become a 0. Okay, so now I can use the same logic again and say mat2 bracket LG underscore mat2 equal to 10. Okay, this is just an optional way of writing part D. It's up to you which one you're more comfortable with. Okay, I'm gonna comment this because I like this way better. Okay, moving on to part E. Okay, let's see. Min sum quad, which contains the minimum sum of quadruples. Let's assume we are adding 4 numbers in vec1 in turn without overlap, since vec1 is a 1 by 4n vector. So this is a row vector, okay? N quadruples can be generated. So since we know it's already 1 by 4n, we know it's all going to be divided evenly, right? So we are going to have like a proper number of quadruples. So let's take a look at the example. When vec1 equals 1, 3, 2, 5, 1, 3, 2, 7. So what are we basically doing? We are making the sum of quadruples, and this is the sum of these 4. So 1, 3, 2, and 5 become 11. 1, 3, 2, and 7 become 13. And what is the minimum one? It's 11. Okay. So how do we start with this? The important thing is to know that we want to get these 4 numbers in order. So the first thing we do is reshape our initial vector. What is that called? I think it's called our vec1, right? So I'm going to call vec reshape res equals. And how would I reshape it? I want it to be a 4 by n. Why 4 by n? Because I want these first 4 to be in the same row. Okay? Sorry, not same row, the same column. Because if I change them into rows, the order of this is going to be not 1, 3, 2, and 5, and then I would lose like the correct order, which is why I need to reshape it into a 4 by n. All right? So let's take a look at this. Reshape vec1, comma, bracket, 4, comma, n. Okay, just to show you why I am reshaping it in 4, comma, n, I'm also going to copy this, put it right here, and I'm going to call this, just for now, I'm going to call this vec res1, and I'm going to call this vec res2, and here I'm going to change it to n, comma, 4. Okay, let's run this and open both vec res1 and res2. Okay, this is a 4 by 15, this is a 15 by 4. Okay, let's open vec res2 first and also open vec res1. Okay, so vec res1 is, oh, sorry, I should also open vec1 because otherwise you won't understand why the difference. Okay, so this is vec1. What do I basically want? I want the addition of 33, 10, 7, 75, and 75. Then I want addition of 55, 34, 84, and 56. Okay, so when I do vec res1, which is basically reshaping it into 4 by n, I get my 30, 10, 75, and 75 in one column. And then what was the next one? It was 55, 34, 84, 56. Yes, do you see that? However, if I turn that into an n by 4, that is not the case. Your 33, 10, 75, 75 is like this. How are you going to sum those four? And the orientation of this is not the sum you want, right? So be very careful with the orientation. If it confuses you, the best way is to always write both, run them, and see which one is the one you want for your question. All right? Okay, so I'm going to be deleting vec res2 and renaming this to vec res1. Okay, let's see here. All right. And after I've reshaped, I also need to take the sum of it. So what am I going to do is min sum quad equals to. So first I need to take the sum of vec res in the vertical direction. How do I get a sum in the vertical direction? By specifying the dimension to be 1. So sum bracket vec res comma 1. All right, so this way I'm getting the sum. And what do I also want? For the min sum quad, I need to find the minimum out of all of these sums. So min bracket, put all of this in the min function, and that's it. So that is my final answer. I'm going to run this now. I have all my outputs. That is great. I'm going to copy my script, copy, and paste it right here. There you go. All right, let's submit this. All right, everything is correct. Hello, we're starting with homework 5, question 3, donut store. So this is similar to the donut store and the candy store questions you've seen in your previous homeworks as well as quizzes. The only difference is in this one you need to use operators and you cannot use loop statements. So let's take a look at the question. Okay, so a raffle will take place at Bianca's donut store. Each customer receives a 10-digit number on their ticket and 1,000 people get raffle tickets. Okay, the ticket number is 10 digits. To win the prize, the ticket number must satisfy the following conditions. So when you're reading this, an important thing is to understand that all of these conditions need to be satisfied. It's not optional. Okay, so for a person to win, they must satisfy each and every one of these conditions. So we have second and third digits are odd numbers. The second last digit is greater than the last. Sum of all digits is less than 40. And fourth and sixth digits are not equal to 4. Okay. We've also been given an example of how a person whose card numbers are this and this will receive the prize. So if you compare those to all the conditions, you will see that they satisfy each and every one of those conditions. And it also says a 1000 by 10 matrix named card num all is randomly generated and each row has a card number. So it's basically 1,000 people and each person gets a like a 10-digit ticket number. Okay, and card num all has already been given to you right here. Write a script to compute the number of price receivers and assign the value to num price rs. So that's what we're looking for. We're looking for the number of price receivers. And the important note here is please do not use the loop statements. So henceforth, if we do not want you to use any loop statements or do not want you to use something, we will mention that very clearly. So if you've been instructed not to use the loop, make sure you do not use any like for loops, while loops, nothing. We'll also be checking for that. Like we'll have a condition to check that you do not have a for loop in your code. Okay, so I copy this right here and I paste it. Okay, so what do we do since we can't use a loop? Instead of having like the for loop that goes through each and every ticket, now we need to store all of this in a vector. So what I'm going to be aiming for is making a logical vector that is going to check how many of my like ticket numbers are actually following each of these conditions, and then I am gonna check which tickets follow all of them using the AND operator. Okay, so let's start by defining our first condition. So usually we write condition 1, but here since now we're generating a logical vector, I'm going to write condition 1 vec. Okay, what's the first condition? So I need my second and third digits to be odd numbers. So we say AND rem. Okay, so how do I get the second number? So here will be card num all bracket all rows, because that's the 1,000 different people, second column because that's the second digit in everyone's ticket numbers, right? So that comma 2 because we need to check for even or odd, so rem and 2 bracket not equal to 0, or I can also write equal to 1 because for division by 2 there's only 2 possible outcomes, right? So this, and I have my AND operator already here, so I'm going to copy this whole thing again, paste it right here, delete the comma, bracket this, and instead of second this will be the third digit, right? So this is my first condition. Let's go to the second condition. So it's condition 2 underscore vec. Okay, my second condition is the second last digit is greater than the last digit. So how would I write that? I would say card num all, oops, bracket all rows, I don't want a space here, all rows, comma, ninth digit because that's the second last. I can also write end minus 1, it's up to me. So for this question I'm going to write 9 because I know that it's a 10-digit number, and this is greater than card num all bracket all rows, comma, either I can write 10 or I can also write end, up to you. Okay, be really careful with the meaning of second last and third last. So second last is end minus 1, it's 1 before the last one, and third last is 2 before the end, so end minus 2. Okay, so here it's second last, that's why it's 9. Okay, let's look at the third condition. Sum of all digits is less than 40. Okay, so condition 3 vec equals to sum card num all. Okay, now an important thing to note is that sum of all digits for each ticket needs to be less than 40, right? So we have 1,000 rows and 10 columns. So to get the total sum of digits in one ticket, I need to sum it in the horizontal direction. So I have to say 2. This will specify the direction in which it will get summed. And this needs to be less than 40. And finally for condition 4, this is equal to, the fourth and the sixth digits are not equal to 4. So that is again 2 little subconditions. So and card num, oh, that became caps lock, all bracket all comma 4 is not equal to 4, comma, I'm just going to copy this because I don't want to write it again. And instead of the fourth digit, this is going to be the sixth digit. Okay, check all my conditions. Okay, they look fine. Okay, now I have to combine. Okay, just to understand what's happening here, I'm going to quickly run this. So if you look at these vectors, do you see this is 1,000 by 1 logical? So what's happening here is basically it is, oh, let it load for a second. Yeah. So it is telling you which of these ticket numbers are actually satisfying that particular condition. So the eighth ticket is satisfying the first condition. So, and then if I check condition 2, the sixth ticket is satisfying condition 1. So what do I basically want out of this? I want only those tickets that satisfy every single condition. However, these are not variables, these are vectors, so I can't use the double and symbol. Instead, I'm going to be using, I'm going to write it right here, num press rs equals to condition 1 vec and condition 2 vec and condition 3 vec and condition 4 vec. Okay, now let's try running this again. I'm calling this numbers rs for the moment. So basically this is checking which ticket numbers satisfy all the conditions. So I guess there's not a lot of them satisfying all the conditions right now. There probably will if I keep scrolling to 1,000, but that is beside the point. But okay, so if it does satisfy, it's going to change the 0 into a 1, right? So if I want to get the number of tickets that's actually satisfying every single condition, I basically just need to sum this logical vector, because that's going to give me how many people actually satisfy every single condition. So now let's run it. Num press rs is 19. So that means 19 people satisfied condition 1, 2, 3, and 4. All right. So that is my answer. Let's copy that right here. Okay, I should not copy cardinum. I'll just the rest of this. Copy this, paste it. I added that comment again. My bad. Okay. Is that, yeah. Submit. There you go.